Why are deep space explorations long-term biological effects on humans unknown? Imagine venturing into the vastness of space, beyond the familiar orbit around Earth, into regions where no human has gone before. Now, think about what might happen to your body after months or even years in such an environment. It's a question that scientists and space agencies are still trying to answer. The truth is, we don't fully understand the long-term effects of deep space travel on humans. There are many reasons for this, and they all make studying these effects quite challenging. First, deep space exposes astronauts to radiation levels that are much higher than what we experience in low Earth orbit. This radiation is made up of high-energy charged particles from cosmic rays that can penetrate spacecraft and human tissue. Over time, this radiation could damage DNA, increase the risk of cancer, and even affect brain functions. But because the radiation environment in deep space is so different from Earth or near-Earth orbit, we cannot predict exactly how it will impact humans over extended periods. Second, microgravity in space causes muscles to weaken and bones to lose density. Astronauts on the International Space Station, which orbits close to Earth, experience these effects for a few months. But when it comes to longer missions, like those to Mars or beyond, we don't yet know if these changes will be permanent or how long recovery might take once back on Earth. Some studies show that even after a year of being back home, astronauts still have not fully regained their pre-flight muscle and bone strength. Third, the psychological toll of being far from Earth, in confined spaces, and cut off from loved ones adds another layer of complexity. Stress, isolation, and the constant awareness of being in a harsh environment can affect mental health and immune responses. But because these factors are hard to simulate perfectly on Earth and because we have only a limited number of astronauts with long-duration spaceflight experience, understanding their long-term effects remains difficult. Training astronauts for future missions involves preparing them for these unknowns. They do resistance and cardiovascular exercises to combat muscle and bone loss. They also get psychological support to handle stress and isolation. But since we don't yet know everything about how space affects the human body over many years, these protocols are always being refined as new research comes in. Most human spaceflight so far has been in low Earth orbit, where Earth's magnetic field offers some protection from radiation. Deep space missions will expose crews to much harsher conditions, making it even harder to predict health outcomes based on current experience. The small number of astronauts who have gone on long missions also limits our data, so scientists are working hard to gather more information. In the end, the long-term biological effects of deep space exploration on humans remain as a mystery because of the complex mix of high radiation, microgravity, psychological stress, and limited data. Ongoing research is essential to better understand these risks, so future missions can be safer and more successful.